All right. Ugh. Okay. Well, well, that's a horrible, horrible view of me. I guess I'll just kind of start off very briefly for those who are kind of watching this stream a bit later on. After this is probably all over, if you didn't catch the stream actually live, um, I kind of wanted to do a little thing, kind of discussing what we're going to be going through. So some of the stuff that I've got in the stream, I've already kind of been doing some kind of work on, but I was really curious to see. I don't know. I just want to have some kind of friends as I go along and kind of design some stuff here live. I can see some people are kind of joining the chat right now. Mini Siren Productions says hi. Liam Emma Air Raid Siren coming in here saying how, introducing himself. I'm doing all right. I'm doing all right, Liam. Just working on some new stuff. So I just want to get that kind of out there. Like again, for those who are kind of watching this a bit later. Some of the stuff that's just kind of going on. So let's go ahead and jump right in, I guess, and we'll just we'll get on to the actual stuff we're gonna be working on today. So this is, of course, Streamlabs. You guys have seen all that stuff before. Mini Siren Production says, "I have your 7T." Oh, awesome! Can't wait to see a video on it. Did you get the? Did you order a poll? I don't know if you ordered a poll or not. Anyway, either way, I hope to see it soon. CNY Siren Boy says hello. Glad to see that we got some returning viewers. Some folks I've seen in the chat before. But I wanted to kind of again talk about a little bit of the stuff we'll be kind of doing today, and this is going to be kind of my first introduction into the first ACA siren I've actually ever worked on. I wanted to kind of jump in with something a bit more interesting in ACA's lineup, and kind of starting with one of the classic ones. Really, the first siren that kind of defined ACA, or in this case, Biersack and Niedermeyer, or Niedermeyer. Kind of one of the defining sirens that kind of really made that company. So, of course, we're doing a classic one here, working on an Allertor. This specifically is this is going to be an Allertor 125. So, one of the ones that has the elongated horn, not so much of the cheaper versions where the horn is a lot more shortened and stuff like that. But kind of like the mid-generation ACA, one of the mid-generation Allertors. This is, of course, this is going to be 912. I know there's a lot of different port combinations you kind of could get with the Allertor, but I don't know. I like a 912. I like the way 912 sounds, and especially I really like ACA's version of the 912, where it's a lot more 12 dominant. As compared to the federal design stators or federal design rotors, where the actual 12 ports is on the bottom. I'll go ahead and show that right here. Whoa! Oh, it's the back of the 500. So, versus the federal design rotors, where the actual 12 ports are all along the bottom, the 9 ports being on the top. So it's a bit more. Usually, I find that dual tone sirens are usually dominant towards the rotor, the stator. Let me rephrase that. Usually dual tone rotors and stators tend to be more dominant towards whatever port is closest to the front. So in this case, this has got the 9 towards the front and then the 12 in the back. And the thing that I like about ACA is that the 9 is in the front, or the 9 is in the back and the 12 is in the front. So it makes it a bit more 12 dominant, which is why ACA kind of has a bit more of a different pitch to it, even though they're still 912, as compared to like federal. So, and also another thing that I really liked about doing some of the designing and the stuff is the ACA rotors. The ACA rotors and stators are, let me tell you, I consider myself a Federal fan. I like all pretty much all of Federal's stuff, from spanning from Federal Electric all the way up into modern Federal Signal stuff. But man, some of the really early Federal rotors are really lazy. I mean, of course, like we can take a look here. This is, of course, a 912 rotor for a 500, and it is just a really simple rotor. It is really simple, and I know kind of what they were going for, with this design, kind of trying to make the rotor unidirectional, so it doesn't matter if it's reverse wired. And I know that that was kind of one of the big things with them. Um, but in doing that, you really sacrificed a lot. You sacrificed a lot, Federal, because it is just not a very efficient rotor design. It is horrible. Um, and of course, there's a big stigma, about dual tone sirens, that usually typically dual tone sirens are nowhere near as loud as single tone sirens, which is true. I think a lot of that, mentality probably is coming from the effect of Federal design rotors, or Federal Signals dual tone sirens. Excuse me. Of course, I'm just talking to the camera here, but I think a lot of that stigma probably is unwarranted. I think a lot of that stigma probably comes from the fact that the information they're going off of is usually based off of like Federal sirens, because with a rotor design like this, it's just not gonna work very well. Um, it's just lazy. It's just lazy, and I think a lot of that is probably just, and I think there's probably a reason for it. It's probably because they were trying to make this as easy to assemble or as easy to cast as they probably really could. Um, but hats off to ACA, or B&N specifically, I guess, if you want to get more pedantic about it, of who really designed the rotor. But it is just a fantastic design. It is super. It's just as simple, but it is a directional rotor. So of course you can get some inherent efficiency gains by making it a directional rotor. But with all these swept vanes here, which drastically increases the efficiency and a lot less drag on the rotor itself as well. And then having the knife edge sharpened ports is just I know. It's just I'm kind of nerding out about it just because of how well it is. Because I've actually printed this rotor. I've printed both of these. So let me go ahead and go to Streamlabs really quickly again and make my stuff really big. Really quickly. Let me read some of the chat. So Mini Siren says, I made a video. Oh, cool. I'll have to take a look at it. CNY Siren Boy says, I'm waiting for my SD10 and 2 poles. That should be okay. Oh, you're CNY Siren Boy. Okay, okay. And yeah, I recognize the. I think I recognized the location when I was shipping them out. Um, you should be getting it probably sometime this week, because I just shipped them Monday. I shipped them out, so you should be getting them pretty soon. Um, Silent 65 Gaming. Yeah, this is my favorite siren you're creating currently. Awesome. Yeah, it's a pretty cool one. It's a classic. It's a classic for a. I'd love to see the fully completed and working Songs Model 120. I have. I mean, you probably have seen the video I've done of the. It's a bit further back in my channel, but that's just the. I mean, it's at least the prototype. Eden actually has my prototype right now. It was way too big to try to bring to South Carolina. But if you want to see it, I can actually show you the model if you want to see it on Fusion. Model L says nice. Awesome. But yeah, as I was saying, I've actually printed both of the rotors. So let me go ahead and jump back into Fusion really quick. So you probably can see me down around one of the little corners, but there's actually one of the rotors right there. That's the rotor for. What is this? This is specifically an ACA rotor. So this is the 912 for, like, say, the Allertor, or some of the like the Allertor or the Screamer, something like that. And then of course there's the 912 from Federal, and it's just, again, it's just really, really, it's not efficient at all. It's just not efficient. And I've made the whole thing. I've gotten the whole rotor and stator, and at the same RPM, which granted these rotors are exactly the same size. I didn't change anything about it. They are exactly the same diameter. I will give it a slight edge to the ACA because it is a little bit thicker, but it's really not that much thicker by much. But it's just so much more efficient. I was amazed when I actually made the little prototype and I hooked it up and heard what it sounded like, because at the same speed as the 500, because I was making a 500 at the same time, at the same exact rotor speed as the 500, the ACA is just so much louder. It is impressive how much more efficient this rotor is. But enough of that. Enough singing the praises of the ACA stuff. Let's kind of jump in and start kind of working on it. So, of course, a lot of the hard stuff is kind of already done. I did that a while ago. I did this last night when I was working on it. So of course we have the rotor here. I'll go ahead and get rid of the stator and motor plate. So there's the rotor. That's our ACA 912 rotor. So that's all done already. It took a little bit of time because I have got some kind of interesting profiles on here, specifically with these kind of blade shapes. Let me go ahead and rotate this really quickly. I don't know why it really likes to favor that. But there was some interesting profiles to kind of work with here. I don't know how well you can see this kind of in the background, but the fin that actually reaches all the way into the center and touches the hub, that one on the real one has a bit of a sweep to it as it goes up, so it kind of flares out as it gets towards the edge of the rotor, and trying to kind of make that was a bit more of a hassle than I was really expecting. But other than that, this was really not that hard to model, so that's why I'm kind of not going over it, because this is the stuff that really consumes a lot of the time. And the stator is much of the same thing. The stator was really not that difficult either. So there's that. But let's get on to some of the other stuff. So we're going to kind of go ahead and assemble all of this. So I've already gone ahead and kind of made the rough general shape of what we're going towards for the Allertor. And there's a couple of engineering kind of concerns here about how this is really going to work, because remember, this is going to be 3D printed, and 3D printing does have its limitations on what it can do and what it can do well, I should say. And one of those things is 3D printing is typically pretty bad about making these kind of like rounded over kind of spherical or spheroid kind of shapes. And in this case, it's a torus that I basically just made a toroid, and then I made another toroid inside that to cut it out to make this hollow kind of donut shape. That you could do that in Fusion. I'll probably explain that in some other kind of video. But the printer has a very, very, very hard time trying to model this kind of rounded over shape. And it also has an even harder time kind of trying to make this little circular cutout on the top that's actually cut out right here, because consider this, the printer essentially is going to be printing this whole thing like this. So the bottom of the print bed is going to be right here, and it has to try to print this really, really slight overhang almost the whole way up, and then it has to do it again at the top, all the while trying to make this as circular as possible. It just really can't do it. Not with the kind of layer heights you have. So here's that same exact piece actually in Fusion, in the slicing program I use. And you can see these kind of printing artifacts right here. Ooh, I'm flipping all over the place. You can see kind of what I'm talking about right there, with this kind of printing artifact right here, which doesn't look that bad on the slicing program, but trust me, once it's actually printed, this whole little shape right here really gets amplified by the just the real world inefficiency, or the real world kind of looseness of the printer, the run out, one could say, because the printer is not going to print nearly as, it's not going to print super precise. It can get pretty good, but that's about as the limitations of what it can do. So that's one thing I'm kind of concerned with. I actually have this piece right here printing as we speak, so it'll be really interesting to see kind of how it works. But moving on, some of the stuff we're going to be kind of working on now is getting the actual kind of doghouse shape, the motor cover designed for this, as well as the actual chassis that the whole thing is going to kind of sit on. Now, I did kind of negate one other thing that is kind of crucial for the Allertor 125, in that, hold on, one sec. Yes, discard that. One of the things I kind of negated on the Allertor 125 is that many people probably don't actually know this, but the rotator, the rotator drive right here actually somewhat cuts into the, and of course this is the Air Raid Sirens wiki. I don't really go on here very much, but they got good pictures. But the actual rotator, the bottom drive sprocket actually somewhat cuts into the housing of the Allertor. So that's a little cutout that's going to have to kind of be right there if you want to try to make it as accurate as possible. So that's one thing to kind of consider. Now, on my version that I have so far, I didn't do that. So this is not cut out like that. So this is probably going to be more akin to one of the later Allertors, which I didn't really want to go for. But I'm already printing the piece out, so there's kind of no point in going back. So this would actually be a bit more accurate to, what the heck is that? Oh, someone 3D printed Allertor already. That looks pretty good, actually. This, of course, is printed in a split section, a little bit different than what I typically did. That's kind of cool. I didn't know someone actually did that. You can see that they're probably using a slicing program like Cura to actually slice that, because you can see all these weird polygonal, this polygonal kind of shape to it. I'm trying to find a good picture of one of the other later versions. Yeah, that's like a later version Allertor where the rotator actually goes above or underneath it. So it's one thing to kind of consider. So I'm probably going to have to end up cutting that out for the final version. But I know that the part I'm printing out right now is not going to really look that good anyway. So I'm probably not going to end up keeping it. So this is kind of what we're going to be working on today. So I'm going to be making this little cutout, making the chassis, making the rotator, the doghouse, all that kind of stuff, and then the associated cone for the front projector, and then the very, very top projector as well, and we'll be kind of working on that. So let me go ahead and read a little bit of the chat, see what the chat's talking about. You might also hear my stomach kind of growling because I haven't had breakfast yet. So if you hear like screeching noises, it's my stomach. So let's see what a little bit of the chat says. So I'd love to see fully completed working model songs. Yeah, okay, I'll go ahead and show you that in just a sec. Let me get to some of the chat. Awesome, I'd love to. I've created 3 Allertors in Blender and currently printing them. Just got a printer, so I'm still learning the printing process. San Joaquin is a model 2. San Joaquin, like up north, like northern California, like right below Sacramento, of course. Got an Ender 3 Pro, 3D printer for Christmas, so I'm using that currently. Cool. If you were to sell this thing, I would buy it right away. Well, I gotta make it. It's just a prototype so far, so we have to make sure it actually works well before I ever try to sell this kind of stuff. I kind of spend quite a bit of time polishing this stuff up. But anyway, so Adam Sturgeon was curious about the 120, so we'll go ahead and show that off really quick, because I never did get a chance to actually cut away at it. So we'll go ahead and open up the 120 right now. This is just the prototype version of it. This is kind of left in limbo, as I never actually finished it. I didn't build the frame around it or anything like that. But this is the 120. This is what that design was based off of. So everything is here. I think I've got multiple analysis points, actually. Okay, so that's a split view of it. So that's our first split view. So this is, of course, all the horns. There's the waveguides right here, which I think I can actually probably isolate. Oh, this is one of my old models where I didn't label anything. So I was so horrible back then. But yeah, for those who have wanted to actually see kind of like a cutaway, a top split cutaway of it, as to kind of what's going on. So here is kind of looking down one of the throats of the horns. As you come down, you actually reach where the fiberglass horns actually meet the cast aluminum waveguides that come off of the stator. And so this is what that profile looks like right here. Right here is what I would consider a resonance trap. That's what this little kind of inclined profile is basically what it's there to do is to prevent as the sound wave travels down the throat of the horn, the waveguide. It is here basically so that the sound wave can't sit here and keep bouncing in between and for some reason ending up going back, because this small little profile here is pretty parallel to each other. It's not necessarily in that kind of horn profile yet. So it runs a risk of having some of the sound just feed back into the actual rotor and stator itself. So it cuts down on efficiency. So by putting this right here, you basically are essentially kind of convincing the sound to move more out towards the horn direction, and it doesn't allow the sound to kind of travel back up the waveguide. But that's what that little weird profile for is. It's a resonance trap. And then as we go inside, you can see kind of this is where we're actually getting to the walls of the stator. So if I actually was to come in here and remove one of these waveguides, so this is this waveguide, there's the walls of the stator itself as we get kind of closer up into it. And of course right here, this is the rotor. You can see as it would spin around. Let me go ahead and see if I can rotate this really quick. Yeah, there's the rotor. Rotate around this axis. So that is the rotor in there. This is a 4-port rotor, which is somewhat inaccurate. It would have been actually a 5-port for the final versions. But this is the 4-port rotor that I've got just in there spinning around. And you can see, and what I had meant, if I had the 5-port rotor, this would make a bit more sense. But I had mentioned in a comment about about an asymmetrical port ratio, where the rotor has, say, either fewer or an odd number of ports relative to the stator, and how that can affect the tone that's created by the Siren 2. It's usually always going to be stator dominant. So if it's an 8-port stator, it's going to sound generally like an 8-port. But one of the reasons why the send and know for a nuclear generating station Siren has such an interesting kind of tone to it is because it actually somewhat acts like a tritone Siren, where it acts like it has 3 tones. And the reason for that is because out here, if you look at the stator, let me see, it's all highlighted. If you look at the stator right here, you can see, I know it's kind of a lot to kind of look at, but here's the stator. It's highlighted in blue, right? The stator on the outside is 8 ports, and the rotor in this case, this is a 4-port rotor, but it would have been 5. The rotor would be 5 ports. But then on the inside, past that stator, past the rotor, there's actually this this deflector that's in there, and this deflector, let's see if I can get a better view of it. This deflector is, ooh, that's a cutaway of the blower. I don't want to see that. I don't want to see that. Let me see a cutaway of the, come on, damn it. Hold on, give me 1 sec. Let me do a different section analysis really quick. There we go. That's pretty good. So, as I was saying, so again, here's a bit of a different view. So if you can follow along with me, I'll kind of explain what's some of the oddities of it. So here's the outside the stator right here. Of course, we have the rotor. It spins on the inside, and then this is that deflector I was talking about. Deflector, diffuser, really whatever you want to kind of call it. I would consider it more of a deflector because it's taking, if you look at the air path, it is taking air directly from the blower. Air gets pulled in here, flung out by this impeller, gets pumped up this pipe into another resonant trap, which is there to prevent the noise from the intake noise of the rotor from traveling back down into the blower and then being heard out the front of this thing. And also, it would cause vibration issues if you have like a really, really low frequency being fed back into the blower. You can cause problems that way too, which is another reason why this thing has that specific shape to it. But the air path comes up and then is fed into this splitter that's in here. And the deflector then takes that air and channels it up here, and it smoothly transitions it to go out of the ports. So you can see that this little angle right here, and it's segmented. It's actually segmented, so it somewhat splits off the air path. So that's that same diffuser from above now, split in half. You can see how there's actually walls to it. So there's walls on either side, basically to separate each port. You can see that here's the port right here, and there's a wall on this side and a wall on this side. So the only way for the air to travel out is the air is pressurized in this area of this diffuser, and as this port rotates around, and this rotor rotates around and uncovers this port, all of that pressure that's built up in here can then be forced out. But the reason why I said that this is more of a tritone siren is because you've got 8 ports out here, and these walls chop the air as well. As this rotor is spinning around, you can see that it's uncovering this little section right here of the wall, allowing some of the air to actually bleed from this edge around the port and into this side, and vice versa. So this basically, the air is being chopped against here, and then it's being chopped against the actual port. So it's more like having an 8-port, a 16-port, and a 5-port because of just the way that the siren is set up, because of all of the stuff that's inside the siren. You're not talking about just the ports that are on the rotor and the ports that are on the stator, because there's basically this diffuser in the center. So that's mainly one of the reasons why that the 120 has such a very, very odd kind of tone to it, is because it sounds like a 16-port, and if you hear in the video of the prototype, you can actually hear that like 16-port kind of whine it has to it, where it's really high pitched. But yeah, so that's the 120, and of course this is all. I wish I had this stuff labeled so I can take it apart a bit better. But that's it for that. I know it's kind of a lot to absorb, and I could spend hours talking about the 120 and the engineering that went behind it, and as to why it sounds certain ways, why it behaves in a certain way. I can go for hours talking about it, but not the point of the video. No one in the chat. Got 3 viewers right now. That's not too bad. So anyway, let's go ahead and jump back into the. This is the 120. Let's jump back into the. Don't save that. Allertor again. We'll see kind of what we're going to be working on. So I'm a little concerned about, again, that little kind of donut shape, that ring that kind of just cuts out a bit of the actual horn. I don't know. It's going to be kind of a bit concerning. So some of the really hard parts are kind of done now, and I'm really curious to see kind of how it ends up getting printed out, because I know that's not really going to be super. I know that little ring is not going to be super clean when it comes out. But let's see if we can model kind of like the front projector, like the first little horn that's kind of on there, this one right here. The intake projector. Let's see if we can kind of do some of that. So I'm going to start off by first coming in here, doing an offset plane really quick, and just kind of filling in this gigantic front space, because we do not need to have all of this hole right here. So let's go up. What size is that? It's like 11? No. 12? Wow, these cop cars are really, really fantastic to listen to all day. Let's do about 11 point... Oh, no. Oh, gotta ease it on up close to it. Let's see, does that get us close enough? Maybe not. That looks pretty good. Alright, so we'll do that to kind of close this in a little bit. So we're going to put the offset plane there. I think the way that, just for ease of printing, I'm going to leave this part generally open on the front, but I'm going to make this part that's going to close it up basically be a separate piece. So let's go in here. I'm not going to go... Oh, that's not centered. I'm not going to make this go all the way to the other edge. Because... Let me make sure I get rid of all that stuff. Because I kind of want to have a little bit of space for expansion here. So how big is that? That's about probably 35, maybe? 60. Oh, that's pretty big. 65 probably. Yeah, about 65. So let's do, instead of doing 65, which would bring us right to that one edge, I'm probably going to go about 64.8, which gives us about 0.2 millimeters of tolerance, which is generally about how tight I make my tolerance on my sirens anyway. So let's go ahead and do that. And we'll just kind of fill in, this little space. Just like I make basically, just to essentially blank off the front of the alerter itself. What is my cat doing? Spice! Sorry. My cats are messing around. So let's kind of bring this up a little bit. A little closer. There we go. So about 1.56-ish. That's close. She just sneezed. I don't know if you're able to hear my cat or not. But let's go ahead and kind of bring that out a little bit. So we're going to make this a new body. We don't want this thing associated with this kind of whole donut shape. So now we essentially have like a sealed little alerter donut face thing. This hole in the back, of course, is to just basically allow the entire stator section to essentially pop through the back of the siren. So essentially this whole thing right here will be printed basically as one big piece, which you've seen in the in the intro of the video of kind of where I was showing off the Prusa, the slicing program I use. That's where that was. Hold on, let me get this video light kind of charged because it's getting darker outside. We're in the middle of a thunderstorm right now. No thunder yet, but a thunderstorm. So now that I can generally see kind of where we're at shape-wise, let me look at their reference image really quick. Man, yeah, I'm gonna have to make that cut out. So I printed this piece for nothing because I'm gonna have to get rid of it. It'll basically be scrap. What in the hell is going on in this? Wendy's? Okay, y'all in the community are wild, and man, that is some wacky stuff. A Wendy's Thunderbolt 1003. Okay, let me see. There we go. That's a really, really crisp reference image. Whoever posted this to the Air Raid Sirens wiki, that's a fantastic picture of the Thunderbolt. Hats off to you. There's a great picture of it. My gosh. You can almost like reach out and touch it. Okay, so let's go with this kind of image as our reference image. So this horn I can see from the edges of the actual torus, the toroid. This horn is about the same size. So we're going to kind of use that as our justification here. So let's first want to cut out the shape right here. Let's first cut out the hole for the intake for obvious reasons, because we need to be able to get air into the siren. I think the center of this is about 35 millimeters, about something like that. Let's do 35 and see where it gets us. So let's cut out the center hole really quick. Oh, perfect. Oh, sweet. Okay, that's fantastic. Okay, let's actually do about a little bit bigger than that. Let's do about 36. 37. Let's do 37. So I can make the wall diameter, or the wall thickness of the horn about 2 millimeters. So let's do 37. Okay. Cut that out really quick. What the hell was that? What was that? I don't know why that wall's there. I'm just going to remove that. I don't know why that's in there. That's not doing anything. So, there we go. Yay, congrats. The Siren can breathe now if we wanted to print this just as this. So now we can kind of move on and see how we're going to make this horn actually kind of fit in there. And this is going to be kind of one of the fun parts, is where we're going to be using the form tool, which I don't think many people have kind of seen. But yeah, we're going to be using the form tool to actually create that swept kind of horn shape. Alternatively, you can either use the form tool, you can either use lofts. Lofts are usually the way I do things when it comes to making horn shapes. But everyone's different. My stomach just growled again. But everyone's kind of different. So I guess we'll start with the loft tool and see kind of where we end up, and if we like that, and if not, we can skip that and we can go to using the form tool and actually kind of making our own custom weird screwy looking horn shape. So let's go ahead and we're going to name this the intake plate, just like that, and we will kind of go on and try to create this. So I'm gonna go with the loft tool with some of this stuff right here. If you guys have seen previous kind of how-tos on Fusion, I've done previous streams, you've seen the loft tool used quite a bit. It's one of my favorite little shortcuts in Fusion for kind of making stuff. But we're gonna use the loft tool here. We're gonna see how it works, and we'll go from there. But in the interim, I'm going to actually go ahead and probably take a quick little break, so I'm going to be back in just a second. Let's see what else we got. What generation Allertor are you going to make? Like 1, 2, or 3, do you think? Probably the 2nd generation. I believe this is the 2nd generation Allertor. I always get confused because they are so similar, and there's like this slight little things that are different about them. But I think this is the generation I'm going to kind of go for. So yeah, I'm pretty sure this is the 2nd generation. I could be wrong. My stomach is going crazy. I'm so hungry right now. I'm fairly certain I had it right. Yeah, I think this is the 2nd generation. I know the really stubby little short one is like the 3rd gen. Is like when they started making them really small. Man, I'm so hungry. Where is it? I don't know where it even is. It's on here somewhere. There's a mobile directo. Anyway, I don't know. I'm probably making the 2nd generation Allertor, but 2nd gen has a circular rotator and 3rd gen has a teardrop rotator. Okay, so that probably means, I mean, they all kind of have a teardrop rotator, don't they? I mean, because they're all chain driven, and the little sprocket always comes out the back. This is one of the weird ones. Okay. Yeah, that's the round rotator you're talking about. Yeah, that's the round rotator you're talking about. I'm probably not going to try to make this one. This one, because it's just so ugly looking, in my opinion. It's just so ugly. I don't like the stubby little horn on the intake. I don't like the way it kind of just like leans back on the rotator. I don't know. So I'm gonna be making that one, the first one I showed you, wherever I put it now, is a really good profile. I'm basically gonna be trying to make this one that you see right here. whichever generation that one is. Again, because I'm not entirely sure, which is kind of embarrassing that I don't know. I don't really mess around with ACA stuff too much, which is why I'm thoroughly impressed with how well this thing sounds so far. So whatever generation this one is. Silent 65 Gaming, yeah, I don't like that one. The intake is weird. Yeah, I don't know. It's really ugly and stubby. So this is kind of what I'm going to. Yeah, pretty sure that's Gen 2. That's what I thought. I'm pretty sure this is Gen 2. I know the Gen 1s are more akin to the B&N, the mobile Directos. I mean, B&N, ACA, it's the same company, really. But, you know what I mean. So, I'm pretty certain the like more of the B&N, that's pretty much like the first gen alerters, but this is kind of what anyway, this is kind of what I'm going to for anyone that's watching this later on once the stream is actually up on YouTube. But I'm going to go ahead and take a quick little break. Um, so I will be back in just a second. I'm going to be going ahead and seeing kind of the progress of the print that's going on right now, seeing what that ends up looking like, because I know that the thing has been kind of going for a while. I've got about an hour left on this print, and I want to check up on it and see how it's doing. Just because, again, I know it's going to be kind of a weird shape to print. So let's see you guys in a little bit. You guys can come back whenever you want. You guys will see me, of course. So I will see you very soon. All right, that took me long enough. I'm surprised some people actually stayed in. They must have actually just had this thing kind of just running in the background. But yeah, it took me long enough to get kind of back. I was just, again, I was really hungry in my stomach was kind of getting really annoying. So I know people probably didn't want to keep listening to my stomach just sitting there kind of growling. So yeah. So let's kind of get back to the task at hand of working with the alerter. I'm going to kind of leave the chat alone for a second as I go kind of back and start kind of working on stuff and getting some of the more important stuff going on. Pretty sure that is a Gen 2, Gen 3. I mean, I have to go back to class. I'll be back at like 12:20. Okay. I guess I will see you then. Silent 65 Gaming. I gotta keep that noted. So I think the way I kind of want to work on doing the horn for this, the intake horn, I think I want to do this by just doing probably just by doing a loft. I don't think I really want to kind of mess with forms. If I have to do the form method, I can. But if I don't have to, I certainly am not going to. So let's kind of go with the easier route first. So let's try that and see what we can kind of go for. The one thing that is also going to suck when it comes to actually getting this thing to kind of work and kind of rotate properly is there is not going to be a lot of space back here. There's not a lot of space back here to fit the rotator, gears, to fit the, because I'm not doing chain driven. I was going to get that out of the way right now. I'm not going to be doing chain driven, but it's going to be kind of a lot to fit the rotator and all this kind of stuff back in here. But the main reason why I also kind of wanted to do the alerter first is because not only is it a very, very unique kind of siren, but by getting the alerter kind of worked out and getting the way its rotator kind of works with ACA, kind of fitting my rotator design into this kind of ACA kind of package. Once I kind of get that figured out, that'll definitely open up the way for doing stuff like P15s, like P10s, all the like the penetrator series of sirens, including like the RM130 or something like that, because it's very similar. And RM130 actually kind of makes sense. A commenter in a couple streams ago, or even might have actually been a video I posted, had even noticed had even mentioned they're like, hey, if you're already making DC sirens, it makes sense to make like an RM130. So it's a possibility. But anyway, working on the alerter and getting this whole design kind of hashed out would open up a lot of opportunities to kind of work with making some more ACA stuff. And I think it'd be kind of a lot of fun. So let's go and kind of see if we can kind of work on making this thing work right. So I think we're going to kind of go off of this diameter, knowing this. I know this diameter of this whole toroid is about probably, I think, 100 millimeters in diameter. So we're going to kind of work off of that. And so let's start off with doing a construction plane. We're going to do an offset plane off of this. Move this out a little bit, kind of at the appropriate distance that it looks on the real alerter. It's probably about, like, by ratio of this is about 40 millimeters that I have on my design. About 40 mils to 60 mils, and this is going to stick out about almost that same distance. So it's about 35, let's do 40. 40 looks pretty good, so we're going to do about 40. I'm going to say about 40 millimeters. Because again, I don't want to make it stubby like this ugly thing. So we're going to go kind of with this. So this is where having these pictures kind of side by side gets really convenient, because I can just do this. There it is. Shrink that down. Oh, you bastard. I want to see the picture. Let me zoom in the picture. No, I don't want to Google search it. Thank you. Okay. Oh, well, I could have gone here. This is this one that's got all the... I really don't like using the Air Raid Siren Wiki, because it's the information on here is not exactly always clear. I Okay, so okay, so the one I'm designing right now is gonna be a Type 3. It's the later version. So Type 2, there's a the Type 2s are just so ugly. There's a Type 1. So yeah, we're gonna go off. We're gonna do the Type 3, the later versions, because I personally think the last generation of the Allotors just looks the best. So we're gonna kind of go off of that. So I wish I could kind of get that picture bigger. Wow, that's perfect. That is perfect. Okay, so now we can kind of get this a bit more accurate here. Let's see if I can move this. Can I move you over a little? Thank you. Okay, so we're gonna kind of eyeball it a little bit here. Try to get the shape to look just right. I'm probably gonna go actually about 45. 45 looks just a bit better. It being just a bit more elongated. And on this generation, the third generation, it looks like the actual edge of the projector is actually slightly larger than that of the actual the toroid itself. So we'll have to keep that kind of in mind. So if this is going to be, I know this toroid is about 100 millimeters in diameter. So let's go ahead and make this other circle over here. Leave that construction plane. That's a perfect place to put that. Perfect place to put that. That's a bit of a, I don't know why I fumbled over those words. Let's go ahead and make this horn. So we're going to go ahead and come here, find the center of this circle. So this should be about 100. I guess it's 95. I was close. 95 millimeters is the diameter of that toroid. So we're going to go out just a little bit more. The projector is slightly larger than the toroid, so we're going to go maybe about 100 millimeters, maybe about 105, and just see kind of how that looks. That's about right there. Let's see how that kind of looks relative to the... Yeah, that kind of makes sense, because the center hole, the intake hole of the horn is kind of small. So let's kind of let's do that. Let's do that. That looks pretty good. I like that. Yeah, I like that design a little bit. We're going to go with that. Shrink that. Make that go away again. Thank you. No, I don't want... No! Thank you. Fusion can fight me sometimes. I'm just a little rusty. It's been a while since I've actually gone back and actually made a new design, so... Just bear in mind, that's probably why I'm a little, like, frazzled when it comes to getting stuff designed. So let's go ahead and... I'm trying to figure out how I kind of want to segment this thing, because I kind of want this to be as easy to print as possible. Because I might actually end up selling these, and I would kind of want to design the Siren with ease of printing and ease of manufacturing, I should say, kind of in mind, so I can kind of make a couple of these pieces in bulk for people to order them. Like for example, the Model 7s are all printed in bulk. I try to print them in bulk at least. Still part by part, but I can print the parts in bulk. So let's go ahead and let's think of something we can do here. I might actually put another construction plane right there. I want to finish that sketch. That sketch is fine. Leave that there. Let's put another construction plane right... Why not? Right there. Let's do it right there. Let me make this one... Can I make this one invisible? Make this one go away, please. Which one is it? Is it this bottom one? No. No, it's not. I just placed that one. Center point, center point, center point. Oh, it's not a plane. It's a sketch. It's a sketch. Idiot. There we go. Let's make that go away so I can see what I'm doing. Okay. So, we'll go ahead and go here. And I'm going to make this circle about the same, generally the same diameter as the rotor itself. So, about 40-ish millimeters looks pretty good. Let's do 40 mils, because that'll give us... Because I know the center of the rotor, this inner edge of the rotor is like 35. So, because I typically make all of my rotors generally about the same size to kind of keep the scale about the same. But in between Sirens, at least for the federal stuff, that's what I was doing. But this is kind of its own new model, so things might be a little skewed. So let's go with 45. I think is when I made that. I think it's 45, right? So we've got this one here. I'm gonna try to make the walls of the Siren, of the horn, about 2 millimeters thick. I think about 2 mils. About 2 mils thick is going to be pretty good, I think. Let's get rid of the stator, let's get rid of this motor plate and the rotor and the torus itself. So I have just the sketches. I'm going to bring that other sketch back, which I just got rid of. There we go. Okay, so this will kind of give us, this is going to kind of give us the shape of the horn. So now that I have these two sketches, I'm going to make a loft between the two of them. And I'm going to do a tangent, or base the whole thing off of takeoff weight. So I'm going to connect the two of those. And it's going to make a really goofy kind of looking horn at first. That's got no weight to it. I'm going to go here, define this by direction, and then I can actually change how much this shape kind of sweeps. And let's see what that looks like. My watch is telling me to move. It's like, reminder to move. I'm like, yeah, I'll look at that. I'll do that in a little bit. So that's kind of getting there. That's already kind of getting there. So that was a lot easier than I thought it was going to be, actually. Let's kind of look at this picture and see a bit of a little side-by-side comparison here. This horn the projector, I should say, extends a little bit past the peak of this torus, a bit more than I would like it to. So let's go back and actually change this size. I should be able to edit that sketch. Let's make this, let's change this. So this, what's the sketch dimension? I made it about 105. Let's make it 100 instead. Yeah, let's make it 100. So let me go back and actually get rid of that. Because it was at the perfect distance. It was at the... What the hell is going on? Excuse me. Yeah, it was at the right distance, but I kind of want to change that size. That's not... It's a little big. So we'll go back, make this about 100. We're not going to do 105. 105 was way too big. It just didn't look right. So let's do about 100, and we'll finish that sketch there. We'll leave it at 100 instead. So let's go back in and get rid of this stuff. Rotor we'll keep, but we'll keep the rotor, get rid of all this rest of the stuff. So go back here. Now I can come back in, do another construction plane, so that it'll separate these two, so that these parts aren't just kind of like glued to each other, which is not really what I want to happen. So we'll do that. So I can get this dimension correct, go in sketch, and make this outer sketch go away. Thank you. Okay. Go into here. What did I make this? 40, I think is what I did. About 40 mils. If I do 38, because this whole thing is about 35, I think. Yeah, 35 from the inner edge of the rotor. So let's do 30. Screw it. Let's do 38. So I can make the walls of this thing 2 millimeters, like I was saying. Okay, so 38, make this, and then we can get rid of this rotor, make the rotor go away, and bring back that sketch that I had made for the front of the projector, and we'll do what I had just done before. Again, we'll go back and do this loft tool again. Between the two of those, we're going to weight the bottom one, and that takeoff weight is a little too much. I want that to be a bit smoother. This end of this profile you're not actually going to see because it's going to be hidden inside the actual donut, the kind of donut shape. So we're going to leave that, and we're going to kind of cross-check it here by bringing that back and seeing if that looks better. And I think it does. I think that looks a lot better. That's pretty accurate to the... Yeah, I think that's pretty accurate to the right shape. So we're going to say that's, we're going to call that good. Now, granted, that is going to bring that all the way to the edge of the rotor, which is not something I particularly wanted to do. So I might actually have to do a cut to kind of get this off of the rotor, because it's a little close for comfort. So let's get rid of the torus really quick, because you can see that it's right up against right up against that rotor. It's really close. So I'm going to kind of come in here, get rid of this rotor again as well. What? Oh, you moron. Why did you bind it to the rotor? Okay, let's try this again. Let me come in here. I'm going to construct a new offset plane off of this sketch. Let's go in about 5 mils is a little too much. Let's do about a millimeter. Screw it. Let's do 2 millimeters. Kind of just to give us enough, kind of a bit of room off of that. It should match up kind of close with the stator. So I want this. I want the inner cone to kind of sit up against the stator, like it does in the real one. So let's do about 2 mils. 2 mils in from that. It's still a little far. Let's do 1. Wow, it's still pretty far. I'm gonna say 1. I'm gonna say 1. We're gonna leave it at 1, just to kind of give us a bit more space off of the stator, and definitely a bit more space off of the rotor. So let's go back and do this sketch again. Same dimension as this, so 38. Finish that sketch. Now can I make that sketch go away, the one I don't want anymore, the one behind it? It's that one, right? Yes. No. That one? There we go. Now we'll do that loft again. So now hopefully it won't actually connect the two of them. I think I made this about 8. That's sure so. Okay, look at that again. That's pretty good. I also apologize for the very, very long delay. The intermission that was kind of in here again because I was hungry. I needed something to eat. I really should have eaten or ate before I started doing the stream. But yeah, that's hindsight is 20/20. So all right, that's pretty good space off of the rotor, I would say. Yeah. That looks pretty good. That should be enough space off of the rotor. So we'll get rid of that stuff again, and now I can basically keep that. So we'll finish that. There we go. So now we can see that the projector is actually solid right now, so we don't want it to be solid. So, and I can come in here, do shell. We'll shell this. We'll make the interior thickness about 2 millimeters, which makes the horn a little thicker. Which would not be, it's not going to be a problem because I've already accounted for that when I did this. So we'll go back in, do another sketch, come in here, sketch this. That is not on center. It's annoying. Come on, hit that point, hit that point, hit that point. Okay, it wants to be difficult. It wants to be difficult. Let's do a sketch here. Okay, so 38, so we'll do 36, which will give us our proper thickness. Go in here, and that new sketch I just made, we'll use that to cut. We can cut out that to make the horn projector actually have the right profile to it now. And where is that intake plate? There's the intake plate. So, intake plate kind of cuts in a little bit. Now if I really wanted to, when I made this profile, I could have actually hit cut and it would have actually manually cut this out. Or it would have automatically cut this little section out to make these two kind of match. But it ultimately doesn't matter. So I'm going to go in here and actually, we're going to sketch off of that, just so I can kind of cut this circle out a bit. So I do need to see where it's actually making contact. Where is it contacting at? About right there, 42, that makes sense. the two contacting. I don't know why it has that funky little like hemorrhoid cancer shape on it, but we're gonna roll with that. I'm gonna cut it right there. And we're gonna cut this part of the ring out. So now there shouldn't be any interference with the two of them. There we go. Now, how does that look once we actually have that whole thing on there? There we go. And that little bit will kind of extend in a little bit, and we'll get really close to the rotor, just like that. So I think the whole functional part is just about done. I think that's just about done. Now, there is one more thing we have to do, and that is I want there to be another plate that will kind of cover up the front of the rotor itself. So let me check the diameter of this stator really quick. The diameter is 60 millimeters. Okay. So it's got to be at least 60 millimeters. Let's get rid of the stator, get rid of all that stuff. So now I'm going to do another sketch off of this. We're going to make this 60 millimeters, so we'll cover up that face. We'll cover up the front of the stator. Okay, so now how much room do I have? I don't think I have a lot of room. No, I don't. Okay. Well, then let's press pull that then. Press pull on two sides. Let's see if this might freak out Fusion. This might really freak out Fusion. I don't want it to cut, I want it to join. Okay, there's not a lot of space there. Let's get this a little closer. So that's gotta come in about 1/2 mil for that to properly sit up against the stator. That looks pretty good. So we're gonna join that. All right, so now this is the kind of shape. This is the kind of shape I've gotten so far. So this part is going to be a real kind of pain to this is going to be kind of a pain for printing print-wise, because I'm going to have to actually kind of come in here and try to manually get rid of or add support material here if I wanted to keep this kind of the way it is. So I will have to add support material, but the good thing is that you're not going to see this portion. You're just not going to see it because it's going to be inside the actual housing, so it's not too big of a concern to me. But this is looking pretty good so far in terms of like a general kind of shape that we're kind of getting for the Allertor. Now I know that front horn is very thick, but I kind of made all these housing pieces a bit thicker than I traditionally do. Mainly because I noticed one thing when I was working on the 500s, when I was first designing those. I tried to make the housings, the shrouds and the projectors kind of as thin as I possibly could, because it makes them nice and like flexible. Like here's the 500s housing. I could bend it and it's not a big deal because it's PETG. It's a pretty strong plastic. But the one downside of it is that it's really, really transparent. So say if I get my flashlight, you can see there's the housing right there. If I shine my light through it, you can see the light like right through the housing. And it's really, really bad when it's in the sunlight because the whole thing is pretty transparent. So it's one of the things that I'm kind of trying to change with some of the new designs. Not that it's a bad thing. It's by no means a bad thing. It's the model looks fine. It's just that when light is shining from behind it, you can see basically almost right through the plastic. So it's something I'm kind of just considering a bit more this time. Let's see if we got anything in the chat. Okay, try to make a Seikomac CS3. With CS3s, the Seikomacs are pretty easy to make. I mean, it's not that much of it's not that much of a modeling challenge. That's probably why I haven't done it. It's just too simple. And for those who are unaware of what the CS3s are, so if I go in here and check the Seikomac. Yeah, there's a CS3. There's a coded one. I forgot. Oh yeah, CS3. It's three-tone. Well, three tones is what they consider it. There's GP3. A lot of GP3s. And there's a CS2. I mean, yeah, I really honestly could model one. It's not that hard to model. I just don't have much of a drive to model it. Like, there's not that much of a... Baby steps is all I can say, because I'm very much a federal guy. I'm used to making federal stuff, so already making an ACA Siren is kind of diverging from what I normally make. But yeah, I can certainly make a Seikomac at some point. I'll probably work on doing some other kind of British Sirens later on. Once I kind of get some dual shaft motors that I really, really like. Because as of right now, my 130 DC motors, that's the type of motor I use. They're really, really hard to find dual shaft variants of it that are going to be that are going to be long enough to work for the scale I'm doing these things in. Because with all of my Sirens, the motor size relative to the rotor is completely inaccurate to how big the motor would actually be in the real one. So the motors are always so much smaller than the actual rotor and stator. So so when I get one of these, it's got dual shafts on it. It's nice it's got dual shafts, but it doesn't matter because the motor's still too small. And on, say, something like a 2T22 or something like that, the size of the motor is what dictates kind of part of the scale. So that's just one thing I have to kind of work around. I haven't really necessarily gotten there yet, but yeah, I certainly will probably make some actual British Sirens in the future, but this is kind of the stuff I'm working on right now. So again, as one of the viewers pointed out, this is modeled after the later version of the Allertor. So that's one thing I have to consider, is I do have to make that little cutout right there at the bottom of this to actually make that fit, which I'm not super excited about because it's going to be just a pain and I got to deal with doing that. But we'll figure that out. So I guess what I'm going to try to do now is this little elbow. Of course, the picture's trying to hide it right now, but this little elbow that's right here that comes off of the actual kind of the pressure case, I guess you can call it. That little elbow, I can already tell is going to be a real headache for the printer to try to model. I might even try to design this piece specifically to be... I don't know. I'll probably try to see if I can design this piece to be printed specifically on the MSLA printer, which I know will probably have a much easier time printing that. But let's just try it. Screw it. Let's just try it. Let's see what we can do. Let's see if we even can just kind of do that. It's a long leg model too. There's a lot of stuff on this thing. Where's it? I want to grab that picture. Come on. I have to make it bigger. There we go. Okay. So, back to that. Let's see if we can try to make that tube that goes off the top. I think I have an idea of how I want to do it. Or how to do it, I really should say. I think I'm going to be doing paths in order to do that. Now, there is pipes, which is an option. Select the path, then specify the section and size. So let's see if I can make a path. This is something this is kind of getting into some newer territory. I haven't actually done this kind of stuff before, in terms of like working with paths. So we'll see if we can do this. Torus coil pipe. pipe. How would this even work? I'm kind of curious about this actually now. Let's see, because I have the center vertex right here. Screw it, let's just try it. Let's just try it. We're both gonna be learning this together at this point. Seeing what we can kind of do. So I have just the torus now. Intake plate. Why didn't you get stuck to the... I wanted you two to get combined. Yeah, I wanted to combine you with the... Let's see if we can do this really quick. Hold on. Okay, there we go. Okay, that's much better. Alright. I'm going to say, rename this to intake projector. Okay. And we'll get rid of that now. Okay, you can probably get rid of this motor plate to the back. Oh no, that's molded into it. Alright, so let's see if we can make the path that this thing is going to kind of want. Let me see if I can first start off by just constructing a new plane. We're going to go through... Is that centered correctly? Yes, it is. We're going to go make a offset plane from there, which I know is centered. And analysis, please. Thank you. I love the analysis tool. Always makes things so much easier. So, let's see if we can make a line. Let's just start doing lines. Create a sketch. We're going to sketch off of this plane. And we're just going to start doing some lines first. Oh, it's going to be an ass about this. I just want to select this vertex, but it's going to be a real pain because it's not going to want me to just select it. There we go. Okay. I really shouldn't even say vertex, it's just a point. I'm going to go up about probably right there, I'd say. Let me see the picture again. Yeah, because the sweep doesn't start for a little bit, but it does start very soon after coming up out of the bottom of that. It's going to be about like right there, 52. 52. What the hell are you doing? Oh no, I want you to... No, come over here. Alright, now we're going to have to make an arc. Let's do a 3-point arc. So I'm going to do this. Sorry for being kind of silent in this section, guys. I'm just trying to make sure I get this right. So I want this to work well. I think regardless of what I do, even if I print it with the MSLA printer, I'm going to have to put support material inside the tube, which is not something I'm really excited to do. But I don't really know how else I could do this. So let's... This extends... I got 59 seconds left on this print. You're going to hear my watch go off in just a second because I'm timing when this print is done. So this is going to be, it's pretty far above that actually. It's going to be about like right there. Not about like right there maybe. It is just like a very big elbow. Let's just see what we can do with this first. Let's see what we can do with this. Yep, there's my watch. Cancel that really quick. Let's just see what we can even do with that. Let's just select that. This pipe's gonna look real goofy. Oh, hold on. Hold on. That's not... I was gonna say that's not horrible, but no, that's actually pretty bad. That looks like dog, man. That looks like dog. Okay, so let's... It's gonna try to cut that section out. I don't want it to cut anything. I just want it to line up. Hollow. Yes, I want it to be hollow. Section thickness, not 8 millimeters. That is ridiculous. Let's do 2. Not 2.7, just 2. 2 point... Yeah, there we go. 2. Okay, let's see how this... I mean, that's close. That's really close. That's surprisingly a lot... That could have gone a lot worse. That could have gone a lot worse. That looks not too bad from what I was expecting it to do. It's by no means perfect, of course. Yeah, I don't like that it's got like this little bump right there. I think it's because I made this whole thing kind of like its own. I didn't define this as like a specific endpoint. But that gives me hope. That gives me hope. I just gotta make that look a lot better, and I think we'll be good. I just have to work on this arc right there, make that arc better. So let's try another arc. Conical curve, no. An arc. Okay, I can do an arc with tangency, that's kind of more my thing. So let's do, wow! Wow, that even might be better. Yeah, let's try that. And then from here, we'll make this extend out a little bit, just like the real one does. Let's try that. Let's see how that looks. That looks a lot better already. Finish that sketch. We'll do pipe again, circular, make it follow that, hollow it out. Again, it's too small. Make this a bit larger. Whew, that's way too big. $35 is a little too big. It's going to touch the walls. Let's do 34. Yeah, let's do that. Make the pipe hollow, obviously. Well, that's not bad. I mean, if this is... that is not bad. I thought this was going to be a lot more of a hassle to kind of make this work. But I like that. I got no problem. I got no problems with that. Yeah, that worked a lot better than I was thinking it was going to work. Distance. I want to change this distance a little bit because it's extending back a little far. Let's see how that looks. Intake. That's all going to be in the way now, but yeah, it just does have that kind of goofy look to it. I guess that's just the way it's going to look. Yeah, it just looks like that. Yeah, that's okay. It doesn't extend nearly as far. It's probably more about like that, actually. Yeah, that's not bad. It needs to be up higher. Um, it needs to be up higher, and the molding needs to kind of make it fit a bit better with this. But I think that's pretty good. Let's get rid of the projector. Let's solidify that. And I'm going to come in here and I'm actually going to cut this back a bit. It's a little long. There we go. It's going to. I don't want it to extend too far into the. I don't want it to hit anything. So like, there's the stator. So the stator, when this by the nature of the stator being in there, is going to kind of cut that off a little bit. Let's just call that the way that is right now, and we'll kind of just we'll assemble the whole thing and see how it looks. That's not horrible. That's not horrible for like a first kind of try. This is one thing that is important though, is that the actual diameter of the pipe needs to be about the same as the intake for the rotor, because that is imperative. Diameter is 30 millimeters. Okay, I think the rotor is 35. That's really close. Whoa, the what? Length. I don't want the length. There's diameter. That's really close. That's really close. Let's see. 35. Okay, I mean that's about a 5 millimeter reduction, but that's pretty bang on right there, I think. Yeah, I think that's pretty good. And then the actual like top projector is not going to be hard. That's not going to be hard to model at all. That's again using the loft tool. Loft tool again does a majority of the work for you, so it's not that hard. It's all dependent on how well your sketch looks when you first do it. So yeah, so let's check. Let me double check all this stuff to make sure it actually modeled it right. So this should be, if I'm correct, this should be a thickness, a wall thickness of 2 millimeters. So diameter is 34.5. Diameter 3.45. Distance. Okay, so two, yeah. Okay, so there's a 2 mil wall thickness. Perfect. Just wanted to make sure that I actually was going to model that correctly, because sometimes it doesn't. Perfect. All right, so that's the basics of the Allertor done. At least I have to model like the front projector, but I mean the top projector, but I don't know. Let's see what else. Silent 65 Gaming, I'm back. Oh, welcome back, man. Yeah, I know it's you didn't miss a lot because I went and I had a very rudimentary breakfast. What I like to use is a manual of a Siren for reference. Like I have one, but I can't find it. Give me 1 second. Okay. I can't find the manual, but if you look up online ACA Allertor 125 manual, a good manual will come and will show you all the parts of the Siren, even the inside of the timer cabinet. Well, I mean, I already know what the inside of the Siren looks like, so that part's not hard for me. And even regardless, like the inside of the actual cabinet itself, the rotator cabinet, the doghouse of the Allertor, or pretty much any of the like the Penetrator series Sirens, are pretty much all exactly the same in terms of how it's done. The problem is that again, since this is going to be a smaller version of that, and my parts, the size of my parts are different than that of the real ones. It really doesn't it really doesn't matter what the inside of the like the rotator section is or the slip ring section, because I'm going to basically have to redesign all that stuff from scratch anyway in order for it to work at the scale I'm doing. So the only thing that I was concerned about was knowing, like when I first kind of started doing this, was knowing kind of like what the rotor looked like and the stator. But the rotor design that I went off of is basically just designed or copied off of, there's a picture, I think up here somewhere, that's got a really good picture of what the rotor looks like. Again, there's that goofy Wendy's Thunderbolt. It should be on here somewhere. Anyway, but it's on here. It's by, I think it's like specifically called like the Civil Defense Museum, which is actually owned. It's a site that's owned by Vanamond 2. If you guys are unfamiliar with his YouTube channel, very old YouTube channel, very old Siren YouTuber, I should say. And one of the ones that kind of got me into making modeled sirens, which if you've seen my Los Angeles Siren vlog, which I posted a while ago now, or like a couple videos ago, that was, there it is. I talked about him and how he was kind of my inspiration for my first model sirens. He was the one who really got me into him. Not by me talking to him. I never actually communicated with this gentleman, but his videos he posted was really what kind of got me into it. So here's the civildefensemuseum.com, and of course these are some of the original reference pictures I went off of. So of course this is obviously must be a third generation Allertor. But this is a picture of that. Here's when it got taken down. It had a bit of rotator damage. Ooh, really bad rotator damage. Actually, the whole track is all messed up. They must have just dropped it. Interesting. But yeah, so this is kind of what I'm going off of. Wow, that's such a weird shape. That's such a weird shape. I'm going to have to try to model. I think I can do it, but it's going to need support material for how I have the donut kind of made right now. But yeah, just some more stuff. 6 viewers. Oh, got a lot of people in the chat right now. Wow, this has been going on for about an hour already. I'm surprised, because I feel like I haven't really talked about very much. But so here we go. Here is the general kind of gist of the Allertor. This is kind of what we got going on right now. It's not too bad. It's not too bad. I'm kind of leaning towards making the pipe right here actually just part of this donut shape instead of having it being its own external piece. Because then it's going to be a piece I'll have to try to make fit on this. You know what? Let's do this. Let's try actually making these two pieces the same thing and then seeing how it works. So I'm going to see if I can kind of make this a little bit bigger. Can I expand this just a touch, please? 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 No. Okay, you're going to be an ass about it. Okay, well, never mind. Then I'm going to go in here instead of just do this. So we go over here, do a sketch, create sketch, blah, 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 blah. Can't see it now. Thanks for moving it to a point I can't see. Okay, so I'm going to come in here, center circle of this. I just need to bring it out just a little bit. Okay, so I'm going to temporarily kind of make these pieces all one piece. Which by doing that, this should actually join this section to the actual donut, the torus. Yeah, let's just do that. Let's join those. And I'm not going to save this portion, so I can actually just like undo that. Let's just see what the printer is going to try to do. Let's try with the tube on it. All right, let's try that with the pipe on it, and let's see what the slicing program wants to do with it. Well, I'm gonna close Streamlabs for just a sec. So let's go close all my tabs out. Let's go open up this really quick and see what the printer tries to do. Of course, this is all of my Siren models right here. Let's go with there we go. Drag that in. I do not want to open it up on Chi2Box. I don't know why. Chi2Box is the program I use for the MSLA printer, because the MSLA printer has a weird, goofy slicing program. Whoa, okay. That is obviously too big for that. Let's drag it in there. Drag it into Prusa Slicer. Wow, this is going to be a big piece. Wow, that's big. Okay, let's see. I want to see kind of generally what it can even do. I know it's not going to look good. Yeah, I didn't think so. Especially, it's going to be really bad, especially down here. Because there's the overhang. There's an overhang right there. Let's add a little bit of supports. Let's add a little bit of supports and then see what it does. If I can print it just the way it is, as one piece, I think I'd prefer to do that. I think I would really prefer to do just that, because it saves me so much time. In the modeling process, or the manufacturing process. Let's see, how is that? It doesn't look too bad. It doesn't look too bad if it was all printed as one piece. It also, I mean, not the modeling process, the manufacturing process. Yeah, that overhang though, right there, that blue section, I'm gonna be printing in free air for quite a bit, so that concerns me a little bit. It does look like it bridges pretty consistently, but this is just straight up in free air. So I might have to support that a little bit. I really don't want to, though. I really don't want to, because I'm feeling lazy. I don't want to do that. Okay, how long is that print going to take? I bet you it's going to be, yeah, 5 hours. That's kind of about what I was expecting, to be honest. But that's not horrible. That's not horrible time. I mean, by far, that's one of the longer prints for one singular piece for a model. Like, I can print like 90% of the 500 SHTTs. I can print a majority of all those parts in like the same time, like 5 hours. So, but for just the housing of an alerter, not counting the rotor, stator, the doghouse, all that kind of stuff, that's kind of a long time, which is a little concerning. Because I'm also trying to keep in mind, I want to make these things print within a reasonable time, so that if I do sell them, I can actually get them out, like in a reasonable quantity. Because I know that my Sirens, they just assembling them and getting them out is usually the hardest part. With my process, I'm trying to keep the prices down as low as I can, so people can actually afford them. I mean, there's no use to making a Siren that people really want if they can't afford it. So it's like I'm trying to make the Sirens as cheap as I can, but it's like it's a lot of time, it's a lot of money for parts and for the materials to actually make them. But it really makes me feel bad when I see people in the chat, or people in like in the YouTube comments who are like, hey, like, I really want the Siren, but I can't afford it. And I'm like, you know, like in my head, I'm like, damn it, like, I really wish I could help, but I'm trying to get them as cheap as I can, as it is. Also, one of the things that I don't think people have actually really realized inside the alerter, but because the later version specifically, is that it's not actually just some open space, just like this. There's actually, when the stator is actually placed in there, there's actually a deflector in the modern ones, like the last generation of alerters. There's actually a little deflector that goes from about like right here on the intake tube, or the I guess the exhaust tube, or the output tube, that actually kind of comes down and covers half of the, like a section of the stator, because since the stator is actually a directional stator, so the air, of course, if you've seen it before, has like those knife edge shapes to them. So I'm trying to see if I can get right here. Let's see if I can get a better picture of it. Since it has like that little knife edge shape to it, the air that comes out of it has a tendency to want to actually spin out of it, rather than just coming equally out all the sides. So what happens is that when the air is actually inside of this donut shape, it tends to want to spin inside of here. The air that's coming out of the siren, it wants to spin around inside this donut, and it doesn't really want to flow up and out through the tube. So on the later versions, there's actually a small little piece that comes down. You actually can see it on some of the. You actually can see it from the outside on some of the other ones if I can get a good enough picture of it. There's a video that Trains and Sirens 1 did recently of an Allertor 125, the late generation, third generation, and you can see when the siren rotates around and you're looking at the siren from behind, you can see that the actual donut, the toroid of it, that's on the shroud, actually has a very, very, very slight kind of volute shape. It's like, think of like a snail shell. It has a very, very slight snail shell shape as it comes out to the actual output pipe. If you guys don't know what a volute looks like, I'll show you that really quickly. So a volute, or a volute, as it's oftentimes also pronounced, looks kind of like this. So this is a volute. I call it a volute. It's probably more pronounced volute, but this is what it looks like. So on the, this is basically just, it increases efficiency because it's allowed to actually, it increases in size exponentially. There's a whole mathematic formula for actually calculating how big of a volute you need, but I'm not going to go through that here. But the Allertor, the last generation, actually has a very, very slight. It looks kind of like this. This is actually a pretty good illustration of one, of what it looks like. As it's tangential, and it comes back and it re-straightens out. It's very, very, very slight, but it's there on the last generations if you look carefully at them. But yeah, I'm very proud of that. That came out pretty good. Let's see what else we have on here. So, can't find the manual. Desert Sirens, hello. Hey, how's it going? It looks good. Yeah, it's looking pretty good so far. Golder, Sarfasu. I apologize. Liam MRA Raid Siren High. Silent 65. Some sirens I've created just. Some sirens I have created, like just the stator and the chopper. I don't get the right prints. Even though I have the chopper a bit smaller than the stator, but I have figured that issue out. Oh, you have? Because I was going to say, if you haven't, one of the ways that I've learned is that, for example, if I go back here, let me go back to Prusa really quick. Let me get rid of this. Go away. If I go back here, actually, here's an even better way of illustrating it, because I got the 500 right here. I pull up the 500. So if you look at the 500, like when you're talking about the rotors and stators, so, and also if you want to be pedantic about it, I know that a lot of people are always referring to this center portion of the siren, the part that spins around and actually flings the air out, the fan. They're always referring to this as the chopper, and this is the stator. Well, in Federal's nomenclature, you can go back. It's on one of their manuals. I think it's for like the Model 5. I think the center, this rotating section of the chopper assembly, this is considered the rotor. This outer portion is the stator, as everyone knows, but those two parts are different. It's not like this is a chopper and the outside's a stator. The whole thing, the rotor and stator, is the chopper assembly. That's the chopper. So if you want to refer to it as the chopper, you're referring to both of them. If you're referring to the fan in the center, it's the rotor. If you're referring to the outside, it's the stator. But the whole thing, when they're both working together, that's the chopper. Because otherwise, I'm like, if this is just spinning in free air, it's not doing anything. It's just the rotor. It's just spinning. If it's got just the stator, it's not moving. It's just the stator. It's only when they're working together is it considered the chopper. That's if you're being pedantic. Honestly, I don't care. It's just one of the things that like I don't know. I found interesting when I was reading on one of the federal manuals that's how they referred to them as. But the way that I make it work is like, say if my print settings are set at like, say this is set at like 1.5. You can kind of think of that as almost like your printer's resolution. Of course, that's not completely accurate because that's dependent on how big your nozzle size is. But I like to behave that this is like a print resolution. So if I have like a 0.4 millimeter nozzle, which is what I think I have, then usually if you want your sizes to work well, you have to account for the size of your nozzle. So in this case, the outside of this, the stator of this is, in this case, 50.4 millimeters. I could have made it 50 millimeters, but the rotor is 50 millimeters. So if I look at the rotor, the edge of the rotor, I don't want the loop area, I want the actual diameter, please. Okay, well this is, now it looks like I just lied to you now. But the diameter of the rotor itself is 49.5 millimeters. So I went ahead, like say if you've got a rotor that's 50 millimeters in diameter, and you have a stator, you can't make the stator 50 millimeters also, obviously. You know that already. You know you need to have a gap in it. You need to have tolerance. So what I typically do, at least with my printer, is that whatever the size of the rotor is, I will usually move that up by either 0.2 or sometimes up to a complete millimeter bigger in the stator. So say if I had, let me go and do something really quick to kind of illustrate what I'm talking about. So say if I go in here, I'm going to knock out a stator, rotor and stator really quick. So if I go in here, make a circle, let's say I make this 50. So 50 millimeters, bring this up in size, 24, why not? And I go down, so this is, let's say this is the rotor. Here, I'll even put a hole in the center to make it look more like a rotor. Okay. We got our stator, our rotor right here. Go down. I'm going to make my stator. Right here. Make it a little bit bigger. Go down. Let's make it, I don't know, 60. Who cares? Now, I obviously can't make this stator exactly the same size as this. So the rotor I know is 50 millimeters. I know my printer's tolerance is about 0.4. So what I'm going to do is I'm going to go in here and make this about 52. 52 is a little big. It's about a 2 millimeter gap in between the rotor and stator. And of course, you know, you've worked with Sirens before. The tighter the tolerance, the more efficient, the more sharp the sound is. So if you have like, of course, if you've got like a rotor that's 50 millimeters and you're away from the walls by 10 millimeters, you're not going to be making nearly as much noise. It's going to be very much of like an airy, kind of like, instead of being like a sharp beep kind of sound, it'll be like a because you're getting a lot of air bleeding through it rather than actually being chopped. So in this case, this is a 50 millimeter rotor. I would bring this out about, say, 50.2. That's a little close. Let's do about 50.5, about half a millimeter tolerance. So now I can go in here, press pull this outside the stator. Press pull the outside of the stator. Come on, what are you doing? There we go. So that now, when I go and I look at it, you can see that there's a pretty sizable gap in between the two of them. But I typically, if you're working, it depends on what kind of plastic you're working with. If you're using PLA, it depends. And also, if you're making your Siren rotors bigger, so if you're making like a pretty big rotor, like say it's like maybe I don't know, like 120 millimeters, like it's pretty big, then I would usually go about making my tolerance a little bit bigger, because with bigger rotors, you have a tendency to have them be a bit more off balance than the smaller ones. So it's something you need to kind of take into consideration. But it's if you want to know the actual number for what tolerance to go by, I would say usually about either half a millimeter for any rotor. It's about under about 50 millimeters, and then oftentimes up to about a full millimeter in space between the stator and rotor for like larger sirens, for larger rotors. But if that I hope that helps out. I don't want to save that, but I hope that helps out at least a little bit. I know that you probably, I mean, you know that already. You can't make it the same exact size, obviously, or else it's going to scrape like crazy. Yeah, of course. Thank you for that. I didn't know that. Yeah, of course. It's something you kind of learn. You'll pick up on it after you've made a couple of them. You'll pick up on it. You'll kind of figure out what kind of works. A lot of it just comes down to experimentation. Like the only reason why I can give you that number off the top of my head is because I've made so many models that don't always work. And then I've just kind of experimented. In fact, one of the ways that you can also kind of see how tight you need to make things sometimes is depending on what kind of like program you're using for actually modeling your sirens. Make yourself a tolerance gauge. It's really easy to do. I'll show you the one I made. It's really easy to do. All you need to do is, let me go ahead and see if I can make my webcam a little bit bigger. Go ahead and explode myself a little bit there, so you can see me just a bit better. Give myself some light. Oh, damn, that's bright. Hold on, sorry about that. But make yourself a tolerance gauge. So I went out, I printed this out of resin, and literally it's just a block of holes. That's all it is. It's just a block of different holes that I believe these go up. Yeah, I have the tolerance right there. So this goes up basically 0.05 for every other hole. So every other hole is like 0.05 bigger than the next one. I did that. I printed this because this is when I was first starting out with my new resin printer, and I was having problems where the rotors, the mounting hole for the rotors to actually slide onto the motor shafts were either they were too tight or they were way too loose, and I couldn't find exactly how tight or how big I needed to make the hole in order for them to be just tight enough. So I went out and I just designed that in Fusion really quickly so I can have a whole bunch of different holes, and I just took the motor, stuck it in the hole, stuck it in the hole, stuck it in the hole until I found one that was tight enough, and then that worked out fine. And you can do the same thing with like, you know, traditional plastic stuff. Like this is just a regular. The outside of this is printed in PETG, and then the rotor, of course, as with all my other sirens now, is resin. So there's the rotor, there's the chopper assembly out of the Allertor. But yeah, there's the rotor and stator. Yeah, I hope that helps. Again, just experiment a little bit. Okay, let's go ahead and put my camera back down to the regular size it normally is, so I'm not taking up the whole screen. Come on. Let's see, come on. I want just the camera. Display capture? It's all falling apart now. It's all falling apart. Everything's... Alright, bye, Liam. I guess I'll see you later, or I guess I'll catch you in the whatever video I put out next. There we go. Why did it move me down so far? That's so annoying. Okay, make myself bigger here. I'm going to kind of adjust myself down to the proper size. Okay. So let's go ahead and get back to the task at hand here. So, hold on. Get this kind of level here. I want to kind of adjust myself just a bit. So, we've got pretty much the hard part kind of done. So I know the printer, I guess I'm pretty confident the printer can do that. So I'm going to leave that part kind of welded together. If I need to break this little tube off later on at any point, it's not that hard to separate the two. So I'm gonna stay right there with it. That looks pretty good. But now I have to make this little flare. Get rid of the volute picture. Where is that little flare piece? Where's the little flare? Where? Oh my god. Okay, so I need to work on this little flare that's right here. That kind of flares out on the end of the tube to actually accept the top projector. Now, that's not too difficult to do. Yeah, that won't be too difficult to do. Let's go in. Let's see exactly where we're kind of sitting at. Okay, we're kind of far back. It is pouring outside right now. I don't know if anyone... You guys probably can't hear it on the mic, but it is pouring outside. Let's go and cut that little flare. Let's make that just a little... Yeah, we'll cut that flare right now. Let's make a sketch. I don't know why it wants to move me way down there every single time. So let's cut this sketch. So that's 34.5. Let's do 36. 36.5. Which will bring us out a little bit. And then I'm going to go back here and I'm going to press pull. Actually, you know what? Let's do this. Let's press pull. Let's make another circle really quick to line up with, yeah, to line up with that. We'll press pull just this like little outer ring. We'll pull this back just a bit, which will give us the appearance of that little flare. We'll join those two together, and then now I can go in and I can cut that back because I don't need to have all of that. I do want the flare to actually be functional. So, I hate how it always zooms me way down to the top. I mean, way down to the bottom of the model. So 30.5, so this is going to be 32.5. Because we have a 2mm wall thickness. So then, come here, press pull. Press pull this back a little bit. This is the beauty of using section analysis, because I can see exactly how far back this is getting cut. I don't want it to cut down that deep, but I'd say probably about right... Yeah, let's do 3mm. That's deep enough, I think. And now I want to clean up this edge, because I don't like how this edge kind of looks. It's very, very sharp on this, and it's also just not gonna print that sharp edge very well. So what we can do is come in here, go to let's do a chamfer on this. So we'll chamfer this edge out a little bit just to make it look a bit neater. Yeah, that looks pretty good. Yeah, make it just a bit more elongated. Oh, don't be difficult with me, Fusion. There we go. Okay, and that looks pretty good. That looks pretty good. So we have that little tiny kind of lip, that little lip that's up here. It's not nearly as long as the real one. I don't really feel there being that much of a need to make it that long, because of course this is 3D printed. It's not being made of, you know, fiberglass. It does kind of extend back pretty far though. It does extend back pretty far. We can make this a bit longer then. Let's make this a bit longer. There we go. All right, let's call that good. I don't want to keep messing with that too much. This is just getting into like detail stuff. Details you can work on later. That's the way I've always behaved when it comes to Fusion. You can always do details later. So, oh, and that also reminds me, that print is actually done of the this prototype little. Oh, it's gone. But the the prototype little version of this kind of toroid little donut hole thing is done. So let's go take a look at it. So I'm going to go ahead and grab it. I'll be right back. You'll be seeing me very, very soon. I'm going to come back and I'm going to bring that little piece out. We can see what it looks like. Alright, so just excuse me for just a second as I go and go grab that. Because I'm really curious to see how it came out on the printer. It might even just fail for all I know. Oh wow. That's actually, that's not horrible. That's not horrible. I could have that could have gone so much worse. That could have gone so much worse. Yeah, that could have been. Man, that could have been really horrible if I didn't. If I didn't sit there and kind of babysit it for a bit. All right. Yeah, that's kind of cool. That's kind of cool. You're also gonna be with me to kind of split this piece up just a little bit. So let me go ahead and make this webcam bigger again, so you guys can see the stuff I've been talking about. So I just put the tripod for the light over there. Whatever, we'll deal with it. So, oh my god, I'm not used to having the video light just shine right in my face. So, this is that little prototype kind of donut I was talking about. So this is that donut shape I was talking about, the toroid shape, the torus. That's kind of how it came out. But you can see what I mean when I say that there's a lot of printing artifacts, because the printer really doesn't like to print that really kind of steep overhang. It can. It certainly can print it, but it doesn't print it very well, as you can see. So that circular little hole looks a bit more ovular than it really should have kind of came out. But other than that, the casing is not bad. This was printed at a 0.15 millimeter layer height. But yeah, that's not bad. That's not the part with the tube included, because I was thinking I was going to print the tube separately. But I think now, seeing that I was able to do that relatively well, I think we're going to slice this. We're going to go ahead and slice this up real quick. I'm going to have it ready to go. We're going to slice it the way it is now, and then get that print started and see how that comes out. But I'm going to go ahead and reassemble. I'm going to assemble this also, and we'll see kind of how this looks kind of together. But first, let's read a little bit more of the chat. So go ahead and see that Liam, MS Aerated Siren, had to take off, so I'll see you again sometime later on. Silent65 Gaming, thanks for all those tips. I will use all of those for my next Siren, of course. Yeah, and of course, if you have any other questions, I think my other streams, if you go up to my channel and you click on my channel and you go to community, I think my older Fusion stream should still be on there. If you need help with any other of the weirder stuff with Fusion, because I've got one video on there, I think, that shows you how to download Fusion or how to do kind of some more complex kind of shapes with Fusion. So if you need any help with Fusion, go check that out. Or if you need help with whatever program you use, I just like Fusion. It's easy. Do you make all of your Sirens out of resin, or do you still use PLA for some parts? It's kind of a hybrid. So my majority of the housing pieces, I'll get this out of the way. I don't use PLA at all. I used to use PLA when I was first starting to 3D print, because PLA is pretty forgivable. It's pretty easy to print with. It's pretty gentle to work with. But I completely got away from PLA like 2 years ago, I think now. And ever since then, all of my Sirens have been either completely printed in PETG, because I wanted the plastic to be kind of strong enough and heat temperable enough that it wouldn't just melt if it was left outside, because I was from California, so California would get so hot it would oftentimes melt PLA. So you have problems with stuff warping, and I wanted to get away from that. So all of my Sirens are printed with PETG, polyethylene terephthalate glycol modified. And then the only things that are 3D that are actually resin printed are either the really, really small like detail pieces, like the name tags, the stuff that's just really that's way too small to print with the regular filament printer, and the rotors. So like this is a STL10 rotor. Probably it's pretty recognizable. There's an STL10 rotor. This is a weighted one, so this has got the dish in the back to actually fit the rotor weight. And then there's a 500 rotor or SD10 rotor. It's the larger scale 912 Federal rotor. This is also resin printed. And then I've got the Model Q. There's the Q rotor, which is also resin printed, and this one's weighted too. So there's the rotor weight in the back. But the reason I print all my rotors in resin now because the resin is so much easier. For at least for rotors, and it usually adds a lot. It's just better at capturing detail than PLA is, or PETG for that matter. Especially when it came to doing overhangs, because like stuff like the 500's rotor there's that big overhang right here on the top, and there's the overhang right there in the middle, and the PETG rotors it couldn't do it. Even though it's not a very big overhang, it was struggling because PETG just is really, really stringy. So I got away from doing that. I got the resin printer to do that. The only Siren I have that's almost completely resin printed is the STL10. That Siren, from stator to rotor to motor cover to the control cabinet, almost the entire thing is resin printed. But I haven't sold that one. I don't think I plan on selling those for a little bit because they're still in prototyping phase, and I've been having problems with them where they're really brittle. They're really the stators are really, really brittle, and I'm concerned about people having them and like maybe like knocking them over and then having it just completely like crack the stator in half, and then it's useless. So I don't know what I'm going to do with those, but I've proven that the rotors work when they're printed with resin. I do have to go in a minute. I will be back in at 3 or 4 if you're streaming by then. I probably won't be streaming that late because I kind of want to be doing a bit more prototyping. I've got some customers that have some Sirens that they want me to make. I'm working on getting more Sirens out for the shop, so I might not be streaming by then. But if I am streaming, I'll probably just be doing like an assembly stream where I'll just basically have a camera set up and I'm just gonna be sitting there making Sirens on the desk. So yeah. But if you gotta go, you gotta go. So I guess I'll see you guys later. But I hope you join in and subscribe or whatever. I don't know if you're subscribed or not. But anyway, I'm gonna go ahead and cut back. But thanks for at least joining. All right, so let's go ahead and get back to the task at hand here. So I'm gonna put my camera right back down where it was. Jump back into Fusion. Been talking for such a long time. My voice is getting hoarse again. So let's go ahead. I want to actually slice this really quick because I want to see if I can actually start getting this printed, because I think this is going to work pretty well. ACA Allertor, Taurus. We'll get rid of this shape. Get rid of that. Yes, get rid of that. Okay. So now I'm going to actually print this and see. Get rid of that. See how this is going to kind of work. So. Let me delete that really quick and put this on the desktop. Yes, I want to replace it. So we're going to upload that onto there, and then we're going to go into Crucial Slicer. Make that smaller really quick. Make everything kind of small really quick for just a sec. I need to go and see my files. There we go. Taurus with AirPod. What? Let me get rid of that one. I don't trust that one. So this should be the right file that we need. Take this, drag that in. This was the one that I had supported, so we're going to support that again. Now I want to make sure this is going to actually be removable support material because I don't want this thing being crazy. and not being able to take the thing apart. So let's look at my contact pattern first, my contact surface. Print settings, support material, wrapped layers, contact Z distance. That's a little close. Let's make that a little further away. Rectilinear. I don't really care if it's any other shape, so we're good. Yeah, that's fine. I just want to make sure it was at least attachable. I wish they gave you the option to actually make it a little bit bigger, so I can actually have it a bit further away. Let's slice that again. Now, granted, this is also 0.15 millimeter layer height, so it makes the whole kind of shroud look a bit smoother. I probably could realistically get away with it being 2, but I don't want to test fate here. I'm just checking right now to make sure this is actually going to print the way I want it to. And that looks pretty good. It's a big void right there. I'm not a big fan of. Let's see. How long is this print going to take? 5 hours, 29 minutes. Let's see if we did it with speed with this one. Let's transfer this stuff over. Let's see if I did a bit of a higher layer height. Let's see if it prints it just a bit faster than that. Some of the detail will be lost, but I don't think many people will really care about that much. About 4 hours and 26 minutes, so it's not that much of a difference. It's not that much of a difference. Yeah, let's just go ahead and print that. I am completely fine with that. Let's just go with that. I'm going to rename it from Taurus because that sounds like I'm talking about like some astrological sign. Let's do, I don't know, Shroud? Yeah, let's just call it the Shroud. And we'll save that. Write that to the card. Take that out. Alright. And now we will go pop that in a printer and see what the printer does. Okay, see ya. I'm subbed, by the way. Oh, thank you. I'm sorry, I haven't gone through my sub list in a while, so I appreciate that. But I'll be back in just a second, and I'll get this print started. All right. Alrighty, let's go ahead and start that print. So this is that, we're starting a print that's got the air tube actually attached to it this time. And we're going to see kind of how that works, how that performs. But now, getting on to some more of the actual design here, we're going to go ahead and see if we can... Geez, we're going on almost 3 hours here. Now we're going to go ahead and get on with some of the other stuff. So, while we're jumping in, we're going to go from having none of that little, not having that little air tube, or not having that front projector. And we're going to see what we can kind of work with this. My Fusion apparently just had a stroke. And we're going to see if we can make that that very, very iconic projector shape that the Allertor has. So let's go on, and actually, you know what? I know what I want to do. I want to actually try to make that little divot on the bottom first. Yeah, I might want to make that first. I might actually want to stop that print and kind of try to model that little round area first before we kind of get super serious with it. Yeah, I might actually want to stop that print. It's not ready. It's not ready. Yeah, so we're going to actually go ahead and abort that print. That print is just not ready yet. I want to go ahead and make sure that this is that it's going to actually catch that little flange kind of at the bottom. Sorry, I just kind of took off without you guys, but I just wanted to make sure I got that stopped before it kind of just kept and did its own thing. But I do want to get that little divot on the bottom. And I don't want to have that print just kind of going and doing its own thing when it's not necessarily done yet. So there's that little bastard sitting out down there. That's really going to be the thing that's going to be kind of really annoying to try to print. I think we can do it though. I think we can do that. So let me see. Let me first off see where the rotor and everything is kind of situated, where it sits. Okay, so it's going to be kind of... I think I know how I'm going to do it. I think I know how I'm going to do it. So I'm going to... I'm going to come in here. I've already made the torus. I don't want to redesign any of this. I think what I can though, however, is I think I probably can start printing the intake cones. That's fine. That part I know, it's pretty much done. So let me actually go in and print this really quick. Well, not print this, but at least get it started. We'll go in there. We're going to slice this really quick, so I know this is going to be fine too. But I want to make sure that this is all going to be kind of making effective use of my time. Or making effective use of print time, really, I should say. Oh, there's so many tabs open. Why the hell are you open? Okay. Intake projector, there we go. Drop that in there. I need supports, so we're going to generate some supports. Yeah, it's messy, but again, like I said, you're not going to be able to see any of that, so it's not that big of a deal. 3 hours and 31 minutes. Wow, that's long. That is a long print. Okay. Yeah, that's long. That's a bit longer than I was really hoping for it to be. Oh boy. Okay. Well, let's change the print settings a little bit. Let's see if support material, detachable pattern spacing. Let's make this pattern spacing a bit wider than that. Let's do like 6. Just so it's a bit further apart. I don't need to have the patterns really densely packed. because it can bridge a 6 mm gap. It's not that hard. So I think it will be able to bridge that. It should be able to. I hope it does. Yeah, we'll just have to see. We'll just have to see how it goes. We'll just have to see how it goes. I think that would have taken down the time at least a little bit. It did. It did. So let's print. Let's get at least the intake projector started. So I'll be right back again. I'm just trying to. Sorry for kind of just abandoning the chat, but I got some stuff going on. Hey, Klumu, awesome. Welcome back. You just jumped in. I'm gonna take off really quick just for a sec. I'm gonna try to get some stuff set up on the printer so that I can kind of make effective use of my time. So we're sitting here. We're working on the Allertor. All right. My cat is complaining. So this is not going to take super long to get this sliced, so I'm just going to do this kind of off camera really quickly. Just so you guys don't have to see me come on and then immediately get back off again. So we're going to put this into here. It's going to be a 3-hour print, guys. It's going to take a fat minute to print that. I'm not super excited about that super long print time. But it's just part of 3D printing. Not everything happens really quickly. will hopefully be kind of like the last little abandoning my chat just because of how busy things have kind of gotten. Discard. All right. So yeah, this is kind of what we're at. Okay, so now I want to make this top projection horn right here. I know it's a bit of a weird shape, but I don't imagine that's going to be that hard to make. Again, because I'm just going to pretty much use the loft tool to do a lot of that work kind of for me. So, keeping that inspiration right there, let's go ahead. Oh, I need to also make that little divot on the bottom of this to actually facilitate having the rotator there, or the rotator, even though I'm probably realistically not going to actually use that section as a rotator. It's pretty much just going to be just for display, just so it looks like the proper part of the siren. But in reality, I'm probably not going to actually use that bottom section as a rotator. But let's go on and try to make this horn. Now, it does sit back kind of forward of the okay, so it's not super far back from the actual front. It sits really, really freaking far forward of the bottom projector, of the intake projector. But let's try. It's also just such a, I swear, the Allertor is such a goofy ass looking siren. I think we can all be truthful here when we say that the Allertor is a really goofy looking siren. But it's part of that goofiness that leads to it being so recognizable, because it's such an interesting one. Let's go ahead and, I know Klumu is from Canada, so he might be interested in seeing some CLM stuff eventually. That'd be kind of fun to do. I mean, the CLM is also really well, at least the rotating CLMs. The Canadian line materials is also another odd looking siren too. I personally, I think out of the Canadian sirens, I think probably my more akin to being more of my favorite out of the Canadian sirens is the CLM omnidirectional siren, because I think that one's really cool. I actually don't need that offset plane. But yeah, I think the omnidirectional CLM is really, really cool. I like that more than I like the rotating one. I'm just making this little kind of tapered section first. So how far away is that? Can you give me dimensions, please? Thank you. 32.5, so 32 and a half. So let's do 32 and a half. Let's do 30. Let's just do 32. Let's do 32. Let's do 32.2. That's, you stupid. 32.2. So that gives me some level of tolerance. But it should be generally still tight enough to fit the tube in there. So now we'll bring this part forward. Bring it forward just a little bit. We're not going to join this. I don't know why Fusion loves to just assume you want to join things together every single time. We're not going to join this, so we're going to make sure this says new body, because we're going to join it to something else. So now we have that. So this little ring is what essentially the top projector is actually going to grab onto. So that's the section that actually slides into this little flared not flared section of this, essentially this flange. So we're going to do that, and now I need to put a construction plane. So I'm going to put a construction plane that's coming off of this that goes about as far out as the projector on the real one goes, which is going to be real goofy. God, it sticks out so freaking far from the... It sticks out so far from the horn. It's so weird. God, the Allertor is such a weird siren. Yeah, it sticks out pretty friggin' far. And this is actually taller than, this is actually a lot taller than I imagined. Coming off of that donut shape. Yeah, like that one's even more insane. That is a very, very rudimentary looking... the fiberglass work just doesn't look very good on that one. Versus this, the fiberglass casting. The method they did for this one just looks so much better than the very early generations. That looks like just absolute garbage. But I guess it doesn't matter. Ultimately, they're still up. Most of them are. So yeah, I'm glad I didn't start printing this yet, because I might have to actually bring this tube up a little bit. Might have to bring that tube up a little bit because it's a little close. Let's see if we can find a picture of an Allertor from the front. Nope, two L's. I always forget that. There we go. That's a pretty good one. It is up a little higher. It is up a little higher than what I have it. It's up a little higher, not by much. Not by much, but by a noticeable degree at least. So in order for this to kind of look better, I would have to actually extend this pipe up a little bit. This is one of the things that's kind of the most annoying about making model sirens, is having to like just barely like fine tune it just to get it to look just right. It really does not want to... Oh, that's why. Let me cancel all that. Stator, motor plate, rotor. Okay, there we go. I might actually have to split this in half again. So let me inspect section analysis. Let me split it from there. There we go. Yeah, I knew I was going to have to kind of split it from a different angle. So let's go ahead and come in here, sketch. We're going to sketch another circle just to cut this tube back out again. Because I need to get in between this tube and the actual donut to give me some more space. So let's cut this ring out of it, which will separate the two pieces now. So now they're going to be their own separate entities again. So cut. Alright, so now there should be an extra body now, because now that this tube is actually separate from this, or independent from this now. Let's bring back the other analysis. I think it was, which one was it? Was it this one? No. No. There we go. Okay. Yeah, I am very glad I didn't just start printing. I didn't just start like printing away. So I need this to come up just a little bit. Even 5 mils seems a bit big, but now we have this stupid little shape. Well, yeah, there's not too many people that are in this chat now. It is also getting on to about 3 hours long in duration, so I think I'm probably going to be cutting this now, letting me kind of work on this this thing kind of independently now. And see kind of what do I come up with. If I do get it functional, you guys will see it in probably a next video coming up. I know there's a couple other sirens I was designing on Fusion streams, and people have probably already gotten to this in their head that sirens that are made on Fusion on the streams probably don't end up actually getting sold. But believe me, they're just because they're sirens that are just really, you're basically seeing the process really early on in development. I mean, for example, the 500 I made, I designed that multiple years ago, and it's only just now getting out, as of like a month ago. So just for you to know, it's just it just takes a long time. But yeah, so I guess I'll probably be heading out. It's getting pretty long in the tooth on the stream now. Like I said, we're getting on about almost 3 hours now. So, but I appreciate you guys watching. Comment, rate, subscribe. I appreciate talking to all you guys in the chat. It was really cool to see you. Thiago de Souza Visalia is the first mini 3D printed Allertor I've seen. Yeah, it's kind of what I want to do. I like kind of doing some stuff that people really haven't seen before. But yeah. So I guess I'll talk to you guys later. I'll probably see you guys in some other kind of episode. Or new video I'll put out soon. Letting you guys kind of see the progress. But I appreciate you guys watching, and I'll see you guys all later. So, again, this is kind of just going off of some of the stuff I was thinking about. So we're going to be probably having this be relegated to more of its own separate kind of video later on, when it comes to doing the Allertor stuff and kind of working with it. I'll let everyone know that the Los Angeles series is still in production. I'm still printing as much as I can. It's really hard to print parts for the Los Angeles series, as well as stuff I want to prototype and get like some new models out at the same time, because I do have one printer. So pretty much I do have to kind of like find free time where I've got a whole bunch of stuff already printed for the Los Angeles stuff, that I have the ability to kind of spend some time printing other things. So that's kind of why I'm working on this now. I figured I had some free time, so I could kind of jump on this and develop some new sirens. So, yeah, that's pretty much about it as to why you're seeing this video now.